Welcome back. In this video, we'll speak about linear regression a little bit more. We'll actually look at the data set that we'll be using for the first assignment. So I've kind of committed to the actual data set that we'll use. We'll use real estate data because I think it's something that most people in the class, even if you don't own a home or you don't rent, say even if you live with your parents, you can kind of get a general sense of real estate data. A house has some size measured in square foot, and based on that size, there's different prices, and there's some randomness within that. It's not an exact thing. There's other factors, but if you were just to look at the square footage in a given neighborhood, if you kind of confined it to a given neighborhood, you could see that as the square footage increases, as the size of the home increases, the price is going to increase. And we're going to get a little bit of randomness because there's other factors. There's how nice the home is. So two homes may be 2,000 square feet, but they're of different quality. One might have some nicer countertops or something, and so that home is going to be a little bit more. In our example, we don't account for that. We just have some randomness. This is what's known as simple linear regression. And it's nice because we can actually graph this. In other examples where we might have 5 or 10 features, remember from our chapter on inputs, we talked about features. So right now we just have 2 features. We have our square footage and our price. And if anyone has any statistics background, we have our independent variable and our dependent variable. Or if you're talking in terms of algebra, we have our function and our function input. And so if we were talking about f of x equals some equation, y, or let's say it's described as mx plus b, and so x would be our square footage and our price would be the output of that. So a lot of different ways to think about it, but essentially we're going to be working with 2 different pieces of data. Okay, so let's get started. First, I have our CSV file, and remember from, again, our inputs, CSV is a pretty common file type. It stands for comma-separated values. Don't worry about the name too much. Basically, all it is you have for each column, we have a row, an instance, as far as the terminology used in the book. So we have instances and features. And so here we have, or if you're used to using Excel, this would be a row. This would be an individual house. So we don't want to, when we're working with this data, we don't want to get too far removed from what the data actually is. So if we think about it, every single one of these rows, every single one of these instances is an actual home sale. And let's pretend we're looking at homes in some neighborhood, in some zip code, and this is home sales for the past 2 years, and every single one of these is a home sale. Okay, hopefully that makes sense. Here is our header, and basically it describes what each column is. Okay, so you can take a look at that a minute and let that all sink in. Hopefully that makes sense. Okay, so this is a little piece of software I like to use a lot, and I've used it before in the class. We won't well, if you choose not to learn the software, that's all right. You can just follow along. If anybody wants to go above and beyond and actually learn the software, that's good too. I can provide some resources and help you with that. But this is a little more interactive command type. Well, R. Let me take a step back. R is actually a programming language, and RStudio is what's known as an IDE for that programming language. But don't worry about that too much. It just offers a different way to look at the data. So the first thing we're going to do is we're going to say our data equals, and we're going to read that CSV file, and the name of that CSV file was realestate.csv. And the first thing I like to do inside of R is there a command, a function known as summary. We can run a summary on that. And so we look at our square footage. So the smallest home sale was 1,000 square feet, and the largest was about 3,000 square feet. And I tried to make this data have some reality. So if you've ever been in a home, usually homes are older ones, maybe around 2,000 square feet, 1,800 square feet, 1,500 square feet, and some of the new big ones, you don't tend to see them a whole lot greater than 2,500, maybe 27, 28, 29. And so let's say the largest home in this neighborhood, it's not an overly wealthy neighborhood. It's the sort of typical neighborhood that you'd see in, say, Port St. Lucie or Fort Pierce or Stuart. And so on the low end, the lowest home sale was $100,000, $102,000, and the largest, say this is a really big house, and it's 3 times as large as the other house, and so this one went for $485,000. Okay. So let's look at some of the other statistics for this data. We have our median. If you don't know what the median is, don't worry about it, but essentially the median is it's sort of like the average, except for it's tougher to skew the average. So if you have an average of, and you've got 10 pieces of data, 10 instances, a single instance can really skew that data. But what the median does is it looks for half the values below, or I'm sorry, it looks for half the instances below a value and half above the value. And that way no single instance can really skew the data. So a lot of people like to use the median. And it's actually, in many cases, a better indication of your data than the actual average, because it's much tougher to skew. The median is actually synonymous with the average. It just basically means what we tend to know as the average. You take the number of instances and you divide it by the total. And so we end up with, that's our average. And in this case, we don't, because we've got 1,000 different, and you can see that here, we've got 1,000 different instances. It's much tougher to skew the data when you have a very large data set like that, so that's good. Our mean and median are very close. And then our price, same thing. So, okay. So what's the next thing we want to do with it? Well, we want to run a linear regression on that, and R is good at that. Maybe a little bit better at visualizing it than Weka, so that's why I wanted to start off with this. We'll move over to Weka, and what you'll actually do your assignment in is Weka, but I kind of wanted to do some overlap between R and Weka, so you can see that these are commonly used things in data mining and machine learning. I'm not making this stuff up, and they have a lot of overlap, and a lot of different tools offer the same sort of thing. So if you go off into the industry and use another tool, it might have slightly different commands and user interface, but you'll tend to be looking at the same different type of features and statistics of that of the software. Okay, so first thing let's do is run a linear regression. So we're going to say some variable equals regression, and don't worry about too much what these commands are. So we're going to, okay, so it gave us back some intercept and some price to scale it by. So that may not make a whole lot of sense, but let's go ahead and plot it. Once we plot it, it'll probably make a little more sense. So let's plot our data. Okay, and that's a little tough to see, so I am going to, give me 1 second here, see what I can do about making that a little more visible. Okay, so that's our plotted data. We have 1,000 points there, 1,000, okay. And so here we have our price along here, 100,000, 200,000, 300, 4,000, 500,000. And then we've got our different square footages scaling from 1,000 to 3,000 in between. And you can kind of see, in general, it kind of goes up as the price goes up as the square footage goes up. But obviously the data is all over the place. You have some outliers. You have some homes that were a large square footage but went for a low price. And you actually have some small homes that went for a high price, and same thing over here. So what we want to do is as in our previous example, what we want to do is find that line that fits. And that's actually what the regression did when I ran that little command. So let me do this. What definitely helps is if you, and don't worry about what this is, this command puts a line on top of our graph, on top of our plot, I should say, that we previously made. So let's put the regression over that. And it looks like it didn't make it. Let me. I may have given, I think I typed this in backwards actually. Oh, yes I did. Give me 1 second. So the price is first and then the second is, so let's try that again. There we go. I apologize. If you're writing that down, if you're following along, make sure to note that I put that in backwards. And so let's view that again, and we'll get a more realistic. I thought that seemed kind of off. I said, why would the price be that low? And so here we have some y equals mx plus b, and we have some intercept, and then we have some slope. And so let's bring the plot over here, and now we can see our line. What happened is, hopefully you can see that pretty well in the video, but it basically tried to make a line of best fit through our data. Okay, hopefully that makes sense. You can see basically what it's doing is it's trying to find a general fit. And so if I were a realtor and I was selling a home that was 2,000 square feet, I would take this data and I would line it up and I would say, okay, on average, I'll probably get about maybe $240,000 for this home. So let me start a little bit higher and see if I can get a little bit more for the home. We always want to take this data and apply it to real world situations. This isn't pure mathematical stuff. This is applied stuff. This is something directly that a realtor could use, and they would probably use a piece of software that they would just type this all in and maybe not even realize everything that's going on in the background. But as computer scientists and data scientists and data miners, we do care about these sorts of things. So keep that in mind. Now let's go ahead and open Weka. Okay, and so Weka uses a file format called ARF, A-R-F-F, which is similar to a CSV. I've already formatted our real estate data to an ARF file, and I'll post that online. You won't have to worry about that, but it's very similar. It's just got some little extra header stuff. So let's open file, and then I put it in data, and then we should have real estate data. And there we go. No pre-processing required or anything. We will just go right to our regression. So we'll be doing under functions, we'll be doing, well, let's do a simple linear regression. Okay, so we have a classifier, and then we don't really have any, it's such a straightforward thing that we don't need to have any options. We'll do tenfold cross-validation, and so let's just click start. So as you can see, here's our equation that we're given, and so this seems to look a little bit familiar. If we go back over to R, here we go. And it was actually this one. So you can see our intercept is roughly 50,000, and our slope is roughly 99. And if we go back to Weka, we can see that it gave us a linear regression. And so we can see that that all works out. One thing to note is this isn't just some magical equation. We actually use this. This is our machine learning. It's learned this. So if I'm a realtor, and what we can do is we can actually use R as a simple calculator. So what I'll do is I'll say 99.92 times, and say I'm a realtor and I'm going to sell a 2,000 square foot home. And then I type this in, so that's where that 2,000 comes from, and these other values come from 50638.82. Okay, so this value and this value come from our machine learning portion of it, our data mining, and this is actually y equals mx plus b. But when you're working in statistics, they actually do it the opposite. They tend to go y equals b plus mx, which from our rules of algebra is the exact same thing. So that's sometimes why you see that in different forms, but don't worry too much about that. But so if you see it in the form mx plus b and b plus mx, understand that they're the exact same thing. And so we get our price. I was a little bit off, but our price for a 2,000 square foot home, if I'm a realtor, I can tell my client that I'm going to get approximately $250,000, and then we can go from there and figure out if it has granite countertops or a nice view and some of the other things. So hopefully that makes some sense, and always remember to put your data back into a real world context. And as I mentioned, this will be the data that we'll be using for our first assignment. So there'll be two parts in the first assignment. You'll be doing your numeric regression. As we previously stated, there's many types of machine learning. The first two in this course we'll be concerned with are classification and regression, and that's and regression is numeric, and that's what we're working with currently. So always take a step back and always say, what part of the course are we working on right now? And that's what we're working on. So stay tuned for another video on classification to explain the other part of the assignment.